Science 10s. Welcome back. Mr. Thompson here. We're looking at section 1.2 on velocity. So if we start with vectors and scalars, I gave you a little video clip to watch. I don't know how much that helped, but anyways, a scalar measurement has only magnitude. Or magnitude only. That means it has a strength, okay? Like 45 meters, that'd be a distance, right? 20 meters per second, that's a speed. So distance and speed, those are considered scalar things. They have no direction involved. A vector quantity has both magnitude, that's how strong it is, and direction, what bearing it has. So 45 meters north would be termed a displacement. 20 meters per second east is a velocity. So displacement and velocity, they're used to describe vector quantities. So let's do a little couple of examples here just to make sure that you understand how to do some calculations on this. So Bart on his skateboard travels 20 meters right and then 200 meters right and then 300 meters to the left. So what's the total distance he traveled? Distance includes how far he went. Well, he went 200 meters and 300 meters, making a total of 500 meters. In B, what's his change in position? Well, he started right at some reference point, and then he went 200 meters to the right, and then he ended up going 300 meters the other direction. And so really, this is where he started, this is where he ended up, and so what is his position? Well, his position should be 200 meters, subtract 300, or 100 meters to the left. Okay? Generally with the direction, we try and put it in square brackets. Okay? You might have seen that. It's shown up above here, right in this example there. In part C, his final displacement is change in position. So we'd show his displacement like this. We'd say that it is 200 meters to the right. You can put a positive if you want in front of it. And then we're adding a negative 300 meters, that's to the left. And so negative 100 meters to the right, or better expressed as 100 meters to the left. Now you might be asking why I'm putting a negative 100 meters right. Well, you see, the negative just means the opposite of right. And so the opposite of right is left. Okay? And as you can see from my diagram, yes, he's 100 meters to the left. All right, question number 2 here. We've got Homer. He drives east at 80 kilometers per hour for 2 hours, and then he drives west at 100 kilometers per hour for 1 hour. What total distance did Homer drive? Okay, well, total distance would be found by figuring out how far he went at each time interval. So for each time interval, like the 2 hour time interval and then the 1 hour time interval. So you would agree with the fact that 80 times 2, that's how far he went east, right? Then in addition to that, 100 kilometers per hour for 1 hour, well, you'd have 100 times 1.0. Now if you total these up together, you get 160 here and another 100, that would be 260 kilometers. Okay? What is his final displacement? So what's his change in position? So here's where we need to make sure we understand that we're using a vector idea. And so for this vector idea, then east is given the idea of positive, okay? And west, consequently, should be negative. It has to be opposite of east so that the mathematics will work out here. And so let's find out what it's going to be. It'll be 80 times 2.0 plus now 100 kilometers west, so I'll put negative 100, okay, times 1. Now the velocity, right, is what really gets the negative, not the time. Time's always a positive thing. And so now you have 160 minus 100, or plus negative 100, would be 60 kilometers east. When we want to figure out his average speed, then what we need to do is we need to think about him having his distance driven over the total time. So the average speed would be the distance over the time, which is 260 over 3 hours because 2 hours and 1 more hour makes 3. 260 divided by 3, with the calculator, let's try it out. Okay, I get 86.6 repeat, which is roughly about 87 kilometers per hour. Notice there's no direction involved there. Okay? Notice the significant digits, right? This has 2 significant digits, 2 significant digits, 3 significant digits, and 2 significant digits. So when I do the multiplications, I want to make sure I'm only keeping 2 significant digits, which is my final answer. It's going to have 2 significant digits. And in part D, what you need to do is you need to take the calculated answer from part B and use that for our velocity. Now, for velocity, we typically put an arrow over top of it, and for displacement, we put an arrow over top of it. The arrow indicates a vector. Okay, so an arrow over top of anything is a vector idea. Look for it. And then over time, now I'm going to put my 60 kilometers and 3 hours, and so we have the following. 60 divided by 3 is 20, and this would be kilometers per hour, and east is my answer here. Okay, so that gives you an idea on how we're classifying vectors and scalars and how they're very different. Scalars, distance and speed, and vectors, displacement and velocity. Thank you very much.